All right, guys, today we are doing lesson 5-1, distance on the coordinate plane. So our goals today is going to be able to use the distance formula to find the distance between 2 points. Okay, so make sure you have your Springboard book, something to write with, and your vocab sheet so you can put that distance formula in a safe place so you can reference it. All right, so we are starting on page 51 here. So let's start by looking at this graph that your book gives us. And it wants us to use the coordinate plane to find the distance between P and Q. So let's plot P and Q and talk about how we can find the distance there. So let's see. We have P is at 1, 4. Here's my point P, and Q at 13, 9. So here's my point Q. So now what they're going to have us do, and we're not actually going to go through and do the whole thing, is we would use different ways to find the distance between those 2 points. Now, if this was a nice vertical line or a horizontal line, all we'd have to do is count. But because we have a diagonal line here, it makes it a little harder to find the distance between those two. Okay, so if we go through and follow the book, they're going to actually have you derive the formula by using making straight lines from here to here. Maybe I'll do a different color, just kind of point it out. Okay. Now, like I kind of just said, we can count with these straight lines to find the values of the distance. And then they would have you use the Pythagorean theorem to find the length of that hypotenuse side, this side here. Okay. But we're not going to do all that. We're just going to jump right to the distance formula part. Okay. So the method that they do in the book is they make you make a right angle and use Pythagorean theorem. Okay. But we don't want to do that every time we have to find the distance of a diagonal line. So instead, we're jumping all the way to question 15 here to get the formula for the distance formula between 2 points. Okay, so here it is. We're just going to have you guys write it down. So given 2 points, x1 and y1 and x2, y2. The distance d between those points is given by this formula. So it's the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so what we're going to do is we're just going to substitute in our x1s and our y1s and our x2s and our y2s, subtract them, square them, and find the square root. Now, if we get lucky and we get a perfect square, then we won't have to do any simplifying. But if we get something that is not a perfect square, we are going to have to write our answer in simplest radical form. Okay, no decimals with this. So no decimal answers. We want exact answers every time. Okay, so let's going to use this formula. We're just going to do some practice problems on the next page, and then that's basically it. Okay, so we skipped a lot of this lesson because we don't need to derive the formula. We just have to know how to use it for today. So here we have 2 points, 12, -5, and -3, 7. So I'm just going to label these really quick. This is x1, that's y1 because it's our first ordered pair. There's x2 and there's y2 because that was the second ordered pair they gave me. Now we could interchange these. We could make the first ones x2, y2, and the second ones. It doesn't really matter which one you label. Just label it as something and keep it consistent. Okay. So I'm going to go ahead and substitute this into my formula now. So we have the square root. And I have, so x2 was -3 minus x1, which was 12. And we're going to square that. Plus, we're going to take our y2, which was 7, and subtract our y1, which is -5, and square it. Okay, so that's the plug-in part. Now let's just do our little arithmetic here and simplify this. Now, if you're really not so good at integer operations, you can always use a calculator. But -3 minus 12 is -15 squared. Plus, if we have minus minus, that changes to plus plus, right? So if I have 7 plus 5, that's going to give me 12. And then we're going to square that. So let's do real quick. We have 15 squared. So let's just punch that in the calculator. Now, the reason I didn't do negative 15 is because it doesn't really matter. Anytime you square a number, you're going to get a negative times a negative, and it's going to end up being positive. So it really doesn't matter if you include the negative or not. But here we do get 225. Plus 12 squared. Well, 12 squared, I know that one is 144. Okay, so all that simplified together, so plus 144 is 390 or 369, right? Yeah. So all that simplifying we got is the square root of 369. Okay, so now we just got to see, is that a perfect square or is it not? Let's double check in our calculator. Now, if it is a perfect square, we're not going to get just a whole number here. If it's not, we're going to get a decimal. Okay, so let's see. Oh, bummer, we got a decimal. So what we're going to do is simplify this radical then, so we get the simplified answer. So if we have the square root of 369, now we did kind of get lucky because they do give us a little math tip on the side there. But if you're not sure about what factors go into it, you can use your calculator to kind of guess and check. So let's see, if I divide by 2, nope, doesn't work. If I divide by 3, it goes in, but this is not a perfect square. So I'm going to keep working. So if I know 3 goes in, I'm going to try maybe 9 because I know 9's a perfect square. So that works. So let's break this down into 9 and 41. So the square root of 9 we can do is 3. That's a perfect square. 41 cannot get broken down anymore, so that's just our answer here. So our distance, we would say, is 3 root 41 units. Okay, so again, we don't want decimal approximations. I want the simplified exact answer. Okay. All right, I'm going to have you guys try 17a really quick. So use that distance formula, and I'll extend my screen here so you can see it on the top. Okay, so try 17a, plug those values into your distance formula and see what you get. Okay, if you did it right, you should have gotten a perfect square number, which worked out to be nice, and you get the answer of 17 units. Okay. All right, so why don't you guys now try B, 17b, 3, 8, and 8, 3, and see what you get. Okay, if you did it correct, you should have gotten this, 5 root 2 units. So let's maybe go through that one really quick. I'm going to go ahead and grab this distance formula and bring it down so I can see it. So we have 3, 8, and 8, 3. So again, label it however works for you, but that's my first point, so I'm going to call that x1 and y1. My second point, x2, y2. So I'm going to go ahead and substitute this in and see what we get. So x2 is 8 minus x1, 3. And we square it. Add y2, so that's 3 minus 8, and square it. So this is going to give me 5 squared plus negative 5 squared. So 5 squared is 25. Negative 5 times negative 5 is another 25. So we get the square root of 50 here when everything is simplified out. Okay, so again, remember, we can't leave our answer like that. So let's reduce the square root of 50, find a perfect square that's in there. Well, I know that 25 and 2 are factors of 50, right? So if I square root 25, since it's a perfect square, I will get 5. What's left over is 2. So there is our 2, or 5 root 2 units for our answer. Okay, so that is the distance formula. So again, it's just a formula. You just have to plug and chug. You just have to know how to use the formula. Okay, so making sure you label your points x1, y1, and x2, y2. So that way when you're substituting them into the formula, you don't get things mixed up. Okay, so that's all I have for you guys today. So I'll see you in the next video for 5-2.